Section 2.3, Quadratic Functions and their Zeros. A quadratic function is a function of the form f of x is equal to ax squared plus bx plus c. That is, a, b, and c are real numbers, and specifically a can't be 0. The domain of a quadratic function is all real numbers. Anything you want to plug into a quadratic works. So the methods we're going to use for solving quadratic equations are factoring, square roots, completing the square, quadratic formula, graphing. If it is possible to factor, then we can use the zero product property after we factor. And remember, that is, once you have two factors equal to 0 being multiplied together, that is a is equal to 0 or b is equal to 0 or both. Just some formulas to remember. The difference of two squares, that is a squared minus b squared is equal to a plus b times a minus b. And perfect square trinomials, that is a squared plus or minus 2ab plus b squared is equal to a plus minus b quantity squared. Let's find the zeros of these quadratic functions by factoring. So, notice that when I look here, I'm looking for a greatest common factor first, and then using any other methods I know to factor. X squared minus 4x has the greatest common factor of x. So I'm going to factor out that x, and I'm left with x minus 4. So then I have it completely factored. That is, now I can use the zero product property, because when I say I want to find the zeros, that's really like saying x squared minus 4x is equal to 0. Now solve it. And since we now know the factorization, that is x times x minus 4 is equal to 0, I can then use the zero product property, that is x is equal to 0, or x minus 4 is equal to 0. I've already got this one, x is equal to 0, so add 4, x could also be equal to 4, and so our solution set is x is equal to 0 and 4. Then I've got 2x squared minus 8. Step 1, look for a greatest common factor. But remember, since trying to find the zeros, that is really, I should set it equal to 0 first. So 0 is equal to 2x squared minus 8. Now I'm solving this equation. So then factor, I see I have a greatest common factor of 2. That is 2 times x squared minus 4. At this point, you can factor this. That is x squared minus 4. That's a difference of squares. So this is then 0 is equal to 2 times x minus 2. Times x plus 2. So then I use the zero product property. 0 is equal to 2. That's going to give me no solution for that piece. So this one really I get to ignore. Then x minus 2 is equal to 0. Then x plus 2 is equal to 0. I get that x is equal to 2. And x is equal to negative 2. So my solution set is x is equal to negative 2 and 2. More factoring. Step 1, always look for the greatest common factor. I don't see one, so now you can force factor by grouping, remembering what are the two factors of 16, negative 16, that sum to be positive 6. So those two numbers are 8 and negative 2, and so that's going to give me 0 is equal to x squared minus 2x plus 8x minus 16. Now I can factor by grouping. That's then x times x minus 2 plus 8 times x minus 2. That factors completely to be x minus 2 times x plus 8. Then use the zero product property. That is 0 is equal to x minus 2, or x plus 8 is equal to 0. Add 2, add 2. 2 is equal to x minus 8 minus 8. X is equal to negative 8. So my solutions are x is equal to negative 8 and 2. Next one, g of x here. I want to see first do I have a greatest common factor, but notice that I do not. Then for some side work real quick, I'm going to look for two numbers. I'm going to use that AC method. A times c is equal to negative 2 times 2. That is negative 4. Now I'm looking for two factors of negative 4 that sum to be negative 3, and those are negative 4 and positive. So then this is 2x squared is equal to 0 minus 4x plus x minus 2. Now I can factor by grouping. GCF on the left is 2x. That is 2x times x minus 2. Plus, notice that the GCF between x minus x and negative 2 is just 1, so you do need to have that 1 placeholder. So that's 1 times x minus 2. Then, when we factor out the x minus 2, we get 0 is equal to x minus 2 times 2x plus 1. Then use the zero product property. That is 0 is equal to x minus 2, and 0 is equal to 2x plus 1. X is equal to positive 2, and minus 1 minus 1. Negative 1 is equal to 2x. Divide both sides by 2. I get that x is equal to negative 1/2. Now I have two solutions. They are x is equal to negative 1/2 and 2. We can only use the square root property if you can isolate a squared term. And remember that when you take the square root of a square, you have to take into consideration that you're going to get the plus and the minus of the square root. So we're going to try these by using the square root method. So step 1, set it equal to 0. 0 is equal to x squared minus 28. Then I can add 28 to both sides, add 28 to both sides. That is 28 is equal to x squared. At this point, notice that I have isolated completely this squared term. And specifically, it's the x stuff squared. And so because of that, I can now take the square root of both sides. Remember that when I take the square root of a square, I get the plus and the minus. So now I have that x is equal to plus and minus square root of 28. But we do need to see if we can simplify this. 28 is 2 times 14. 14 is 2 times 7. So I see that this is really plus or minus 2 root 7. So I get two solutions. Those x's are negative 2 root 7 and positive 2 root 7. G of x being equal to x minus 6 squared minus 25. Step 1, we need to set it equal to 0 and then solve it. Notice that here I have x stuff being squared. So if I can isolate the stuff squared and there's no x terms on the right, then we can use the square root property. So I'm going to add 25. Then I'm left with x minus 6 quantity squared is equal to 25. At this point, because this is a single thing being squared, I can take the square root of that. This is then going to be plus and minus square root of 25, and so I get that this is x minus 6 is equal to plus and minus 5. Now always remember that that's really two equations. That is x minus 6 is equal to 5, and it's also x minus 6 is equal to negative 5. At this point I need to solve both of those equations. So that is add 6 to both sides, and when I add 6 to both sides I get that x is equal to 11, and then when I add 6 here I get that x is equal to positive 1. And so I get two solutions. X is equal to 1 and 11. Same thing here. Set it equal to 0. Then can we get the squared stuff isolated? And the answer is yes. If I add 48 to both sides, then I get that this is 2x plus 3 quantity squared is equal to positive 48. Take the square root of both sides. Then remember that the square root of a square is plus and minus, so this is then 2x plus 3 is equal to plus and minus root 48. Will it simplify? 2 times 24, 2 times 12, 2 times 6, 2 times 3. So I see that this is really plus and minus 4 root 3. Then two equations, that is 2x plus 3 is equal to 4 root 3, and 2x plus 3 is equal to negative 4 root 3. Two equations. Then subtract 3. That is 2x is equal to negative 3 plus 4 root 3. Divide by 2. X is then equal to negative 3 plus 4 root 3, all divided by 2. Here, subtract 3. 2x is equal to negative 3 minus 4 root 3. Divide by 2. I get that x is equal to those two things. When you're entering these into MyLab, sometimes it will be okay to enter it as negative 3 plus or minus 4 root 3 all over 2. But sometimes you will have to enter them as two separate answers, as that's what they are. So just be aware of that. And there we are. Now to talk about completing the square. And so the idea is this. We're going to start with our standard quadratic equation, that is ax squared plus bx plus c equals 0. Then we're going to transform it into a perfect square trinomial. And transforming it is a weird statement because really we're just going to add 0 in disguise to make this thing work. And that's really weird, but that's what's happening. So what are the steps? So first off, you would need to move the constant over. So anytime you have a quadratic, you're going to move the c to the other side. Then you're going to make the leading coefficient by dividing everything by whatever a is if a is not 1. Then you're going to add b over 2 squared to both sides. Now when you do this, realize that what you're really doing is you're not changing the equation, because equality means that if you do anything to the left-hand side, as long as you do the exact same thing to the right-hand side, you haven't changed the value. Then we're going to factor it. And once we factor this, it should look like exactly those types of problems we just did, where we can then use the square root property. And that's what we then do. Use the square root property to solve for x. So let's get this through once. So let's say we have 2x squared minus 14x minus 1 is equal to 0. And we're trying to solve this via completing the square. Step 1 is we need to move the constant to the other side. So we're going to add 1 to both sides. So we add 1. Then the next thing we need to do is we see that the leading coefficient a is not 1. And since it's not 1, I need to divide everything by whatever that is. So I'm going to divide it all by 2. Okay? And we're going to then get x squared minus 7x is equal to a half. Now at this point, we then need to add b over 2 squared to both sides. Now remember that b is right here, and the sign matters. So it's going to be b is equal to negative 7. Which means that when we add, we're going to add b, which is negative 7, over 2 quantity squared to both sides. So negative 7 halves quantity squared plus negative 7 halves quantity squared. Now at this point, we need to do two things. We are going to need to simplify this side. But I also want to say that if you have put this in the correct form, that is this b over 2 right here, quantity squared, this thing will now factor nicely because it is now a perfect square trinomial. This is a minus 2ab plus b squared. Okay, the a is 1, so it's really 1 squared. But this then factors as x minus 7 halves quantity squared. All you have to do is take whatever this b over 2 is, write it there, signs have to match, and then it is factored completely. Then we can use the square root property. We're going to take the square root of both sides. Okay? So when we take the square root of both sides, we're going to get exactly what we have below. That is, x minus 7 halves is equal to plus or minus square root of 51 divided by 2. Then we're going to finish solving it, add 7 halves to both sides, and when we add 7 halves to both sides, we're going to get 7 plus or minus root 51 over 2. And so our solution set would be 7 plus root 51 over 2 and 7 minus root 51 over 2. So now let's try to solve this one by completing the square. Step 1, write it equal to 0. So that is x squared minus 6x plus 5 is equal to 0. Then move the constant over, so minus 5. That's then going to be, leave yourself some space, x squared minus 6x is equal to negative 5. So now we need to add b over 2 squared to both sides. But for our purposes, b is negative 6. So this is going to be plus negative 6 over 2 quantity squared. Now I'm going to go ahead and simplify that because that's really negative 3 squared. And so that's fine. So then I'm going to add that to both sides. That is plus negative 3 squared plus negative 3 squared. Alright, so now I'm going to erase my side work. Then what happens this is now a perfect square trinomial. Specifically, it's going to factor as x, and then just rewrite whatever this term is inside the parentheses, the b over 2. It's negative 3, so this is x minus 3 quantity squared. Then that's equal to negative 5 plus negative 3 quantity squared is 9. That's fine. And so now I have x minus 3 quantity squared is equal to 4. So then take the square root of both sides. Remember, we get the plus and the minus. So this is then going to be x minus 3 is equal to plus minus square root of 4 is just 2. And then I'm going to add 3 to both sides. And that's going to give me x is equal to positive 3 plus or minus 2. And don't leave it like this, because this is really 3 plus 2. 3 plus 2 is 5, and 3 minus 2 is 1, and so our solutions for x are 1 and 5. We have 0 is equal to x squared plus 4x minus 8. Then I need to first move the constant over, and I'm just going to move it around. We have x squared plus 4x minus 8 is equal to 0. So step 1, move the constant. Then I've got x squared plus 4x is equal to 8. Notice that I've given myself some space for the adding of b over 2. b is 4, so I'm adding b over 2 squared to both sides. So that's going to be plus b is positive 4 divided by 2 quantity squared plus positive 4 over 2 quantity squared. 4 over 2 is 2. And so this now factors nicely as x. Just write whatever's inside the parentheses. That's plus 2, because 4 divided by 2 is 2. Quantity squared is then equal to 8 plus 4 over 2 is 2. 2 squared is 4. Then I have x plus 2 quantity squared is equal to 12. Now I can take the square root of both sides. Remembering that when I take the square root of a square, I get plus and minus. The square root of 12 is going to be 2 times 6, 2 times 3. That's going to leave me with x plus 2 is equal to plus and minus 2 root 3. Then just subtract 2 from both sides. Then I get that x is equal to negative 2 plus or minus 2 root 3. That's then going to be x is equal to negative 2 plus 2 root 3 and negative 2 minus 2 root 3. Now that we have completing the square, let's pretend that you're given ax squared plus bx plus c is equal to 0. And let's say that you find a general form for the values of x. Well, what can you do? You could actually complete the square using all the variables as they're written, a, b's, and c's. And if you complete the square on this standard form of the quadratic equation, then you will get this. That is the quadratic formula. That is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now the beauty of this is that when you're trying to solve quadratic formulas, if someone tells you a certain way to solve them, at least for now you should definitely do that. But realize that factoring is limited, but completing the square is not. And since completing the square is not, then the quadratic formula, being a byproduct of completing the square, is not limited either. These things will always find your solutions if you have a quadratic equation. That is, ax squared plus bx plus c is equal to 0. And so if you want to memorize the quadratic formula instead of completing the square all the time, then you can add it to your repertoire. That is, once again, x is equal to negative b plus or minus the square root b squared minus 4ac all divided by 2a. So we're going to use the quadratic formula to find these solutions. So the things to first remember is that a is 2, b is positive 8, c is positive 2. I'm getting those from the coefficients of x squared, x, and the constant. Then the quadratic formula being x is equal to negative b plus or minus the square root b squared minus 4ac all divided by 2a. I then just plug everything in. That is, x is equal to negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 2, all divided by 2 times 2. Then let's just simplify everything and do as much arithmetic as possible. So this is then going to be x is equal to negative 8 plus or minus the square root of 64 minus 16 divided by 4. 64 minus 16 is going to be 48, so that is negative 8 plus or minus square root of 48, all divided by 4. Square root of 48 does simplify as 2 times 24, 2 times 12, 2 times 6, 2 times 3. That's 2 times 2 root 3. So this is negative 8 plus or minus 4 root 3, all divided by 4. At this point, we do need to reduce it as much as possible. Notice that there's a greatest common factor of 4 in the numerator. So that's the same thing as 4 times negative 2 plus or minus square root of 3, all divided by 4. 4 divided by 4 is 1. And so I now get that x is really negative 2 plus or minus square root 3, which could also be written as x is equal to 2 plus root 3, negative 2 minus root 3. Quadratic formula again. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And then I need to find my a, b, and c, but realize that this is not in the correct form if we want our a's, b's, and c's. And so remember that it came from ax squared plus bx plus c. Notice that this is not in that order, so I should rearrange it just to keep myself on track. 3x squared minus 4x plus 2. Then my a is 3, my b is negative 4, and my c is 2. In the long run, when you get used to doing this, you don't have to rewrite it, but just realize that it must be x squared's coefficient is a, x's coefficient is b, and then the constant term is c. So then x is equal to negative 4 plus or minus square root negative 4 squared minus 4 times a times c, all divided by 2 times a. So then we get this is positive 4 plus or minus the square root of 16 minus 24 all over 6. Then notice that what's going to happen is we get 4 plus or minus the square root of negative 8 all over 6. At this point, remember that this is not a real number. And if we're only looking for the real solutions, this has no real solution. Now if we want to solve for graphing, it's true that we can plot the graph and look and see where it crosses the x-axis. Because really zeros are just x-intercepts. That's all they are. Anytime we talk about finding zeros of any equation, the question is literally asking you, what are the x-intercepts? And so we're doing it algebraically, but understand that if you had a correct graph, your x-intercepts are also those zeros. Please be careful though. That is, if you're graphing by hand, remember that you're graphing by hand and you're not a computer and you're not going to be perfect. So please be wary of taking whatever your picture is as full fact. Let's graph this using transformations and then hopefully we can get a pretty good idea. So what happens here? Well, remember that this is a vertical stretch. This moves it left 3 and this moves it down 2. And it's facing right side up because that 2 is positive. And so my new vertex is actually going to be down 2 left 3, and so that's the vertex of my parabola. Now the vertical stretch actually increases things by a factor of 2, so if you guys recall, you could pick these points and see how far up they go. But I claim it's just as well, we might as well calculate them anyway to get 2 points graphed by hand. Well, what values should we choose? I think we should pick negative 4 and negative 2. Now I have reason to pick those, but some of that's just intuition after practice. And so let's plug in values. Let's see, what is g of negative 4? G of negative 4 is going to be 2 times negative 4 plus 3 quantity squared minus 2. That's going to be 2 times negative 4 plus 3 is negative 1. Negative 1 squared is positive 1. Positive 1 times 2 is 2, and 2 minus 2 is 0. Then I can plot that point, negative 4, 0. And the reason that I knew to pick that value is because I remember that on the unstretched parabola, once I find the vertex, I really get to go one to the left and one to the right, and then up or down depending upon my sign. And this being a vertical stretch of 2 really told me that that single value doubled. That's a lot going on. If nothing else, just pick values. Then I'm going to plug in negative 2. So g of negative 2, that's going to give me 2 times negative 2 plus 3 quantity squared minus 2. That's then 2 times positive 1 quantity squared minus 2, but that's just 2 minus 2, or 0. And so then at negative 2, 0. And so really I've now found the x-intercepts. You could have used the square root property to find that. That is, set this equation equal to 0 and then solve it. That would have been the other best way. And so the x-intercepts are the two values, negative 4, 0, and negative 2, 0. If we want to find the points of intersection, first off, let's understand what those are. That is, two graphs intersect where they share the same point. Or if you're looking at the graph, it's where they literally overlap. The other way to say that is when they're equal. So if you have two functions and you set them equal to each other, you can just manipulate them algebraically and solve for the x's, and the x's that you find will be the values where they intersect. That is exactly this. Set our equations equal to each other, solve for x, find the ordered pairs by plugging in the x values. So we want to figure out where this f of x and this g of x overlap. So step 1, set them equal. X squared minus x plus 2 is equal to 2x squared minus 3x minus 46. My first thought to solve this is put everything on one side because it's quadratic. I want to get it in standard form. So I'm going to subtract x squared, subtract x squared. That's going to give me negative x plus 2 is equal to x squared minus 3x minus 46. Keep moving things over. I'm going to go ahead and do two steps at once here. I'm going to add x, and I'm going to subtract 2, subtract 2. Then I get that this is 0 is equal to x squared minus 2x minus 48. At this point, pick your favorite method of solving, but personally, I'm going to go to factoring at first just because I believe it to be easier, but quadratic formula will always work. Completing the square will always work. Factoring is the only one that really has our limitations. But this one does happen to factor. Looking for two numbers that multiply together to give me negative 48, but sum together to give me negative 2. That gives me x minus 8 and x plus 6. So then using the zero product property, that is 0 is equal to x minus 8, and 0 is equal to x plus 6, add 8, x is equal to positive 8, minus 6, x is equal to negative 6. I get two solutions, x is equal to negative 6 and positive 8. So that means if f of x equals g of x, then x is going to be negative 6 and 8. But if I want to figure out where those points intersect, then what I need to do is I need to take each one of those values and plug it into at least one of my functions. Because the truth is if you plug it into one, that's where they intersect. We just figured that out. Then the output value will be the same for both. And if you want to definitely make sure, you could just take that value and plug it into each function just to make sure that's true. But I'm just going to pick the one that I think looks easier to evaluate, and I think I'm going to calculate using f of x. And so if I want to find the points of intersection, I'm just going to find f of negative 6. F of negative 6 is going to be negative 6 quantity squared minus negative 6 plus 2. I get that that is 36 plus 6 plus 2. that is 44. And so I now know that one of the points of intersection is the value -6, 44. Now to find the other one, so I'm going to use f again, but I could use g, be perfectly fine. F of 8 is then going to give me 8 squared minus 8 plus 2. 8 squared is 64. Minus 8 plus 2 is -6. 64 minus 6 leaves me with 58. So now I have the other ordered pair where these two graphs intersect. That is the point 8, 58.